Quick question before I start. I know this is not in your packet. I don't want it to go in your packet. Anybody want to tell me, leading into the midterm in less than 2 weeks, what I know about those two triangles with all those markings on there? Anybody know anything about those triangles? And I already gave it away anyway up there, but they are congruent to each other, yes? Are corresponding sides equal? What is, bless you, Matt, what does CA correspond with? Okay, what's BC correspond with? Okay, what's angle A correspond with? Angle D. So all the corresponding angles and sides are congruent, right? So the triangles are congruent. By the way, quick question before I move on. Why didn't I mark B and E congruent? Why don't I need to mark B and E congruent? How do you know they're congruent? Ooh, yeah. Third angles theorem. Yep. Good review. All right, so here's what we're doing today. Those are congruent, but how do I make two triangles similar? Okay, what's the difference between those two being congruent and two triangles being similar? All right, well, let's talk first. Here we go. So on these two triangles, let's label them ABC and DEF. Corresponding angles still congruent. If the triangles are similar, ready? A is still congruent to D. B still congruent to E. And C still congruent to F. And I don't need to mark that because we talked Y. Here's the big change. The sides are no longer congruent. The sides no longer congruent. But the sides will be, if I put my pen worked here, 3 and 9. Stay with me on this one. 4 and 12. 6 and 18. The sides are not congruent, but they're what? In the same ratio. Okay? That is the biggest difference, guys, between two triangles that are congruent and two triangles that are similar. The sides are not congruent, but they are in the same ratio. Yes. All right. Let's talk about that ratio. What is that ratio the sides are in up here? 1 to 3, right? 3 to 9, 6 to 18, whatever you want. All right. That ratio is called our scale factor or similarity ratio. Okay. That's the ratio of two corresponding sides. And again, be prepared for scale factor and similarity ratio to be used in all the problems. So do you see the difference between two triangles congruent and two triangles similar now? All right, the biggest difference is the sides aren't equal, they're in the same ratio. All right, but just like congruent, remember we used to write triangle so-and-so congruent to triangle so-and-so and made sure what? The sides all matched up and the angles matched up. Same thing with similar triangles. So if I go triangle ABC, how would I have to name the second triangle so all the angles and sides would match up? Triangle DEF. And the only other thing we need to discuss now is what the heck is the similar sign? Because you guys are so brainwashed right now to put congruent, 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 but they're not. They're similar. The symbol for similar, right there. We are in high school, so we don't call that the squiggly anymore. Everyone ready? It's called the tilde. Tilde. Let that roll off your tongue. Tilde. Is it necessary that you know that? Nope. But be prepared to get roasted if you want to go. It's the squiggly sign. All right, the squiggly sign. All good. Quick midterm review. How many ways were there to prove triangles congruent? Nice. You got that quick. Nice. 5. Well, I'm going to make it easier for you. Only 3 ways to prove triangles similar. Only 3. Okay, only 3. First one, let me introduce it to you right now. Angle, angle. I laugh because some of you think that's the way to prove triangles congruent, but all right, that's the way to prove. Well, first way, angle, angle. What's that mean? Prove two pairs of angles congruent. You got them similar. That's it. Why don't I angle, angle, angle? I don't need. We already know the third angle is going to be congruent, right? So that's why you only need two. All right, let's scroll. Now I'm going to start asking you guys some questions and hitting some numbers. Explain why these two triangles are similar by angle, angle. Why are they similar by angle, angle? What did I already give you congruent? Name two angles that were given congruent to you. Come on now. Okay, here we go. Let's hear from 7. Good talk. Let's hear for 16. What two angles did I give you congruent, Thomas? There you go. So angle H is congruent to angle S. That was given. I'm just doing kind of like a mini proof here. No statements and reasons. Can you find another pair? Because I got to go angle, angle. I already have one A down. Where's the other A come from? 9. Name them. UOH congruent to EOS. Those are what type? Vertical angles congruent. Got it? And that's it. We're done. This is great, huh? No sides needed. Nothing. Only two pairs of angles. And then you could say triangle. I'm going to have somebody give me a good statement now, please. Good similarity statement. 7. Great statement. 18. Okay, hold on. HUO. Yep, similar to triangle. SEO. I like it. How many of you need to leave the room right now because you're embarrassing because you wrote the congruent sign instead of the similar sign? It happens. All right, just get out of that habit. It's only the similar sign. All right. By what method? Angle, angle. All right. Yeah, Thomas. Tomorrow, correct. Using angle, angle. Yep. Anything else from you guys? All right, there's method 1. Method 2 of proving them similar should look pretty familiar. Yeah? Side, angle, side. All right, so let's talk. Angle's still got to be in the middle. But now, the sides are not congruent. The sides will be in the same, thank you, ratio. Okay? The sides will be in the same ratio around that angle. So let me just show you before we go to the example why these two triangles are similar by side, angle, side. Ready? Everyone see the angle in between? What would the 10 match up with in this triangle over here? The 10 would match up with the 15. And the 12 would match up with 18. Now, I need your help. How can you tell those are in the same ratio? How do I tell that 10/15ths and check if it's equal to 12/18ths? How do I check if they're the same? Caleb, one way. I could reduce, basically you're reducing them, right? You could reduce them. 5 goes into both, that's what, 2/3? 6 goes into both, that's 2/3, so they are equal. Anybody know maybe a quicker way to see if two ratios are equal? You've had to learn this way. What do you got, stud? Yeah, cross multiply. Does 15 times 12 equal 10 times 18? And it will. So that's another quick way to see if two ratios are equal. All right. So does everybody see? And your calculator will simplify for you. If you put 10/15ths in your calculator in a fraction template, it'll come back reduced, I believe, most of your calculators. All right. All right, so why are these two triangles similar? What did I give you already? What's the angle that's congruent up here? Let's roll. Number 1, Matt. What's the angle I gave you? Yep, so angle A, we know is congruent to angle D because they're what type of angles, Matt? Right angles are always congruent. So I got A and D. And now tell me if the sides are in the same ratio. Can you guys set up some ratios so I can compare them for me? Here we go. We got 28 in the house? 20. Nope. Oh, we do? That was another class. Sorry, Claudia. Give me a side from one triangle. Okay, what's the 8 match up with in the other one? Okay, so does 8 over 6, is that the same ratio as what other sides am I left with here, Claudia? 4 over 3. Yes?
Does it matter which way we put the ratio?
Nope. If you decide to do 8 over 4 equals 6 over 3, that's fine as well. Okay? Or 6 over 8 and 3 over 4, that's fine. As long as you are cross-multiplying the same numbers. I don't care how you set it up. See what I mean? Okay? So are these in the same ratio? Same ratio. Yep. 24 equals 24 when I cross-multiply, so that's in the same ratio. Give me a similarity statement now. 6, give me a similarity ratio. Great job. 17, similarity ratio. What's that? I didn't mean that. That's my fault. My fault. Totally my fault, Captain. Similarity statement. The 2 triangles, sorry. No. I just want this triangle similar to this triangle. Name them for me in the correct order. So triangle BAC. Oh, one job. She did it. One job. Nice job. By what method? Okay, everyone take a look. Not acceptable. Not acceptable. When do we use this? Prove triangles. Congruent. How do I separate the two? You put the tilde there. Okay? If you just write side angle side, that's for proving triangles congruent. We didn't do that here. All right, so if you're proving them similar, add the tilde. Anthony. Half point. See you later, because you didn't prove them congruent. Any other questions? Angle, side. Third and final method. Also looks pretty familiar. Side. Again, are all the sides congruent? Nope. All sides are in the same ratio. Okay. Quickly up here, before we go to the questions. Why are these 2 triangles similar by side? First question I always get, how do you know which sides match up? It's a great question, right? Because you're looking at here, you're like, where the heck would the 5 match up with over here? Make this easy on yourself. Small side to small side, large side to large side. Okay, when you start matching them up to see if they're in the same ratio. I say that now. What would the 5 now match up with in the bigger triangle? 10, small side to small side. All right, here we go. What's the 8 match up with? 16, and the 13 matches up with 26. And then does everyone see they're all in the same ratio? Last thing before I move on. Hey, you are not a winner if 2 of the ratios come out to be equal. And the third one's different. They're not similar. All 3 ratios to use side need to be the same. All good. They need to be the same. 2 out of 3 won't cut it. Doesn't make you a winner. Whew. All right. Are they similar? If they are, prepare to tell me a method. So these first 2 triangles, are they similar? If you think they are, give me one of the 3 methods. Who can we hear from here? 24 in the house? I am. What do you think? Similar? Well, let me start from the beginning. What did I give you already? What's marked for you? Yep. And what can you do on your own that you know is congruent? So are they similar? By what method? Okay, you're not off the hook yet. You got a statement, triangle. Okay, I'm good with that one. Thank you. RXQ. And you said by what method? Yep. And yes, no, you don't need to put the tilde on. It's up to you. All right, for angle, if you want to add the tilde on. Angle, specifically for similar. So. All right, what about the next? What 2 methods could it be? It could be, what 2 methods could it possibly be before I test it out? 26 in the house? Hi, Jack. I'm doing all right. Or, okay, you're going to make a big class decision for everybody now. Which one are we going to, because if it's similar, it's going to be both. So which one do you want to test? All sides. Okay, here you go. It's going big dog now. We're going to go test it by side, side, side. Match up two sides for me right now. 20, match up two sides for me, Claudia. Okay, so does 9 over 12. Is that the same ratio as? Match up another pair of sides for me. 20 again. You're on fire, Claudia. 12 over 16. And is that the same ratio as one more? What do you think, Claudia? 23 for 3? Nope, 21. 26. 15 and 20. Look at that. Yep. Full circle, as we like to say. Can you guys test if they're all in the same ratio? All three are those in all three in the same ratio. Reduce in your calculator, find the decimal, whatever you got to do. It's tough with three ratios to do cross multiplication. So, are they all the same ratio? Yes, no, maybe. 11. Fiona, what do you got there? All in the same ratio? Yeah, they are. So, yeah, triangle. You want to give me it, Fiona? This PMX. WLA. Okay. By what method, Jack? Nice, good. Yeah.
Would there be a time where you could prove it, like they'd be similar by side and side, but it wouldn't be?
If they're similar, right? Other questions? And finally, this last one. Is there anything you can find on your own on those? Well, actually, where's 6? Good talk, 6. 18? Okay, but what method could it possibly be? There's only one method it could possibly be. Side angle side, right? Because you got the vertical angles. So that's the only method I can test here, side angle side. I got vertical angle, so there's the angle. Now I have to figure out, are the sides in proportion? So give me a pair of sides that match up for me. Give me a ratio here. 16? 2? Where do you see a 2 on that diagram? Or is there a 2?
Yeah.
There is where? Okay, calm down with the attitude. 2 to what? Two to 4. Got another ratio, Thomas? 4 to 8?
Yeah. MP equals MP.
I can't, if you come up here, I can't even, this looks like a 3 to me. What's going? Wow, look at that, huh? Okay. That was fun. I think it was supposed to be a 3, but okay, whatever. Sorry. So 4 to 8, got it? Because this one was supposed to come out to be not similar, but obviously it is, right? Because 16 equals 16, so triangle. I'll have to change that after class for next year. Yeah, because there's a 3 here. That's why I was like a 2. All right, good talk, good story. Just a waste of time. 25, got a ratio, got a similarity statement for me? What was the other? By tilde. Questions? Yes.
For the AA, you have to add the tilde at the end.
Nope.
Since it's like
Angle is reserved for similarity, so it's the only weird reason I'm having you guys add the tilde here and here is because these are ways to prove triangles congruent as well. Okay. Oh, good. All right, now what happens now after the triangles are similar? Now we start setting up our own ratios and solving it for x. All right. Probably one of my top 5 word problems of the year right now. Probably number 5, but it made the top 5. All right, let's read about Natasha. She is going to place a mirror on the ground. Yep. 24 feet from the base of an oak tree. Oak tree, everyone. Not redwood, not pine, oak tree, because that's probably going to be important. She's going to walk backwards from that mirror so she can see the top of the tree in the middle of that mirror. And at that point, Natasha's eyes are 5.5 feet above the ground, and her feet are, what's that say on yours, 4 feet? 4 feet from the image of the mirror. Can you help Natasha find the height of the oak tree? All right, help her find the height of the oak tree. Okay, so other than definitely being correct and saying somebody's got a lot of time on their hands, and why do I feel some of you would try this out one day? All right, put your mirror down, walk away. Do you see the top of a tree, measure the distance? Can you help me identify what the corresponding sides are? So let's start with the 5.5. The 5.5 corresponds with what side in the other triangle? X, yep. So that ratio is going to be equal to the ratio of the other 2 corresponding sides. What other 2 corresponding sides do we know? Here you go, yep, 16. What other 2 corresponding? I know 5.5 and X correspond. What other 2 sides correspond? 4 and 24. Everyone all right how we set up that proportion? I just put the 2 corresponding sides equal to each other. And yes, I'm not going to do this for free. You are going to have to calculate this out. Whenever you are ready to go, number 18, let me know. $30? $33. You going to leave it naked or put something on there? Feet. There we go. Is this the only way to set up the proportion? Nope. You could have flipped it. You could have said 5.5 over 4 equals x over 24 and cross. As long as you're cross multiplying 4 and x, 5.5 and 24, you're correct. All right, next one. This is where we get crazy. First thing, do you see the 2 triangles in the diagram? One is within another, yes? Okay, let's see if you can match up the corresponding sides then. Give me one pair of sides that correspond. Give me one pair of sides up there that correspond. It's got to be full sides, not partial sides, full sides. Okay, 20, you're up here, Claudia. What do you got for me? Give me 2 sides that correspond. What's that? Way to take the easy way out. I love it. Thank you. 17 and X. All right, here we go. 23. Don't say anything. I just want to know a side of a triangle and the smaller one. 15. All right, everyone ready here? What that missing number we're going to put down here is. What side corresponds with 15? And the answer is not 10. 10 is not a full side. 15, take a look, corresponds with this full side, which is how long? 25. Are we all right why I'm putting 25 here and not 10? 10 is not a full side. I need a full side that corresponds with 15. You will get a little decimal action out of here, so don't freak out as you start computing this right now. Whenever you're ready there, 23 again, whenever you're ready, Emma. .6? Okay, that's correct. 28.3 repeating, right? Yeah. Is it all right if I just change that 0.3 into a fraction? 1/3. You can write 0.3 too, that's fine. Excuse me. All right, next up, everyone see the two triangles again. Somebody give me a ratio of two sides. 28 here, nope. Why don't we just 18? 3 to 8. Yeah, Bella, taking the easy one. I like it. 3 to 8. The other side, what's the other given side in the smaller triangle? Okay, let's talk about this. 4 does not correspond with x. How do I write? Here's 4. Here's the side it corresponds with. How do I write how long that side is? I cringe when I ask this. It's not x. Can we do it? Can we do it? 23. Thank you. And I also get 4x. 4x is multiplying the sides. You got to add them together. All right, get after it. You're going to get another fraction, unfortunately, here. Well, unfortunately. You're in 9th and 10th grade. Get over it. $16 when you're ready. Yeah. 6.6 repeating. Look at you putting in a fraction, Thomas. Nice. 6 2/3. Nice job. Any issues setting up? Can you feel comfortable setting up your proportions tonight? All right, I got one more to do with you. And that deals with the perimeters. And we're calling it a day. You can start the homework. All right, what do I know about these two quadrilaterals here? They're similar. Can you find the scale factor, meaning the ratio of two corresponding sides? What's the only side I know in this one? In this polygon, what's the only side I know? WX is 4. How could you find out which side should match up with WX in the other polygon? Is there a way I can do that? Well, how do you know that's the smallest side? Might be the biggest side, right? Touche. How do I find out? And trust me, I am not the visual guy where I can shift it in my head and find out, oh, these match up. I can't do that. Not going to happen for me. Not going to happen. Is there another way up there that I can figure out what WX matches up with? What do you got there, Madeline? You mean the statement? Yeah. Hey, remember, it's in an order for a specific reason. So everyone take a look. Everyone see where WX is? What letters are in place in the first one? MQ. How long is MQ? 8. All right, so the scale factor. Wait a second. Whoa, wait. If I go 4 to 8 and you go 8 to 4, those are two totally different ones. One's right, one's incorrect. How do I figure out which one to put first? Go back to the directions, everyone. Read carefully. What do I want my scale factor? Which polygon to come first? MNPQ, which had a side of, so I want it 8 to 4. If you want to write 2 to 1, whatever floats your boat. 2 is not good enough. Don't just write the number 2. It's got to be 2 to something. Yes, Anthony.
Can we leave it as a fraction or not?
Sure. All right. Last part, what's the perimeter of each? What's the perimeter of each polygon? Can we go to the large one first? Because that's already done for you. 23, what's the perimeter of the large one? Yep, 34. Now, how can I get to the perimeter of the smaller one? Okay, I could find all the sides. I could do all these proportions, find the sides, and add them up. There's a quicker way, though. See the scale factor? The ratio of the sides? That is also the ratio of the perimeters. So the perimeters are also in a ratio of, ready? 2 to 1. Where can I put that 34 we just found? With the 2 or with the 1? With the 2, because it's the bigger one. So whatever the ratio of the sides are, it's the same as the ratio of the perimeters. And now you guys can solve that pretty easily, I hope, and find that, what is the 17? 17, look at that. Way to end it. You're going to go and start the homework now. Hey, a little warning. I found out the hard way this morning. Your online textbook has a new look to it. And I don't know how many of you are going to like it or not. Okay, so just giving you a heads up. Your online textbook's got a new look to it. I'm not a big fan, just to say it, but maybe you like it better. Let's go. Give you an option here. Let's get started. Grab a book or